Whether you realize it or not, our world is going through a major transition as we speak. We are entering the era of artificial intelligence and machine learning, a future where machines will be doing many of the jobs that humans are currently doing today. As a result, the software industry is preparing to go through a major transition as well. In the past, we have had to explicitly program a computer step by step to solve a problem. This involved a lot of if then statements, for loops, and logical operations. In the future, however, machines will teach themselves how to solve problems on their own. We just need to provide the data. Now, this is radically different way of working with the computer than we used to as software developers and IT professionals. While there's growing demand for individuals with these skills necessary to implement artificial intelligence, there's currently a shortage of people capable of teaching machines how to solve problems in this new way. As a result, those with the skills necessary to leverage AI are commanding significantly higher salaries. And this trend doesn't seem to have any end in intelligence. What makes a person, an animal, or an organism intelligent? Intelligence is difficult to define. However, various fields of study have proposed numerous definitions over the years. Unfortunately, most of these definitions are often unclear, imprecise, untestable, and biased in a human centric way. So let's take a step back and start with a few examples of intelligence that we can all hopefully agree on. For example, human intelligence like a person solving a complex math problem to pass a math exam, animal intelligence like a mouse remembering a path through a maze to eat a piece of cheese, and collective intelligence like a colony of ants coordinating an attack on an invading insect. In each of these cases, there's some form of intelligence at work. They are all three very different kinds of intelligence. However, they all definitely share a few things in common. So, what do they all have in common? First, they all involve an agent of some kind, for example, a human, a mouse, or an army of ants. Second, they all involve an environment of some kind, for example, a math exam, a maze, or an ant colony. Third, they all involve a goal of some kind. For the human, it's to pass the math exam. For the mouse, it's to eat the cheese. And for the ants, it's to protect the colony. Fourth, they all involve an agent pursuing its environment. The human reads the math question, the mouse sees the walls of the maze, and the ants smell the scent of the invading insect. Fifth, they all involve the agent taking an action. The human solves the math problem, the mouse navigates the maze, and the ants attack the invading insect. In all of these cases, we have an agent in an environment that is perceiving the environment and choosing actions that it expects will lead to a goal. Given these examples, a simple general definition of intelligence might look something like this. Intelligence is the ability of an agent to perceive its environment and to choose actions that increase its chances of achieving a goal of some kind. But there's a lot of complexity hiding in this simple definition. It doesn't discuss several of the key components of intelligence like learning, knowledge, reasoning, and planning. What makes artificial intelligence different from natural intelligence? So there are two types of intelligence, natural and artificial intelligence. Natural intelligence is the type of intelligence that living organisms are born with and acquire over their lives. This includes organic intelligence like that of humans, animals, insects, and even bacteria. It also includes collective intelligence like a school of fish, a swarm of bees, or a colony of ants. Artificial intelligence, however, is a type of intelligence that is not naturally occurring. It is intelligence that was created artificially by humans using machines. So artificial intelligence is the ability of a machine to replicate natural intelligence. This includes replicating human-like intelligence, other organic intelligence, or collective intelligence. Essentially, if a machine is capable of recreating the same decisions and actions that your natural intelligence would produce, then it is a type of artificial intelligence. More precisely, artificial intelligence is the ability of a machine to perceive an environment and to choose actions that maximize the expected likelihood of achieving a goal. So we refer to this as the rational agent approach to defining artificial intelligence. But this is a lot to digest at once. So let's break things down to make things easier to understand. In artificial intelligence, the agent is a machine of some kind. This includes software running on a computer, a robot, or any other kind of man-made artifact. By environment, we could mean the physical world, as is the case with robots and self-driving cars. However, it could also mean virtual worlds like video games, a computer simulation, or a set of data. So by actions, we mean physical actions like moving, grasping, and speaking, or virtual actions like producing data as an output or making a decision or prediction of some kind. By expected likelihood, we mean the statistical probability of success that an agent associates with a given action. AI agents maximize their chances of success mathematically using software rather than organic brains. And by goal, we mean any objective that the agent was designed to achieve. This could include physical goals like cleaning your living room floor and driving you safely to work, or it could include virtual goals like winning a video game or solving a complex math problem. This rational agent view of artificial intelligence is what most AI researchers, practitioners, and academics use as their guide to define AI. However, the general public tends to have a quite different definition of AI than the experts. Their definition is constantly changing as technology is improving. Once some cutting edge AI technology becomes mainstream, the general public typically stops referring to it as AI. There are three main types of intelligence: artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. Artificial narrow intelligence or narrow AI is a type of AI designed to solve a very narrow set of specific problems. For example, IBM's Watson can play Jeopardy, Amazon Alexa can respond to basic voice commands, and Google's Waymo is a self-driving car. This is a type of AI that currently exists, is growing quickly, and is rapidly changing our world. So artificial general intelligence or general AI is a futuristic type of general purpose intelligence that can solve a wide variety of more general problems. General AI is commonly associated with sentiment robots in books, TV, and film like R2D2, data from Star Trek, or HAL 9000. This type of AI does not yet exist and is still likely many years, if not decades, from becoming a reality. However, this is the general direction of AI and the goal of many AI research projects. Artificial superintelligence or super AI is a type of futuristic AI that is smarter than all human or natural intelligence. Super AIs are typically the supervillains in sci-fi movies. For example, Skynet from the Terminator, Ultron from the Avengers, and the Architect from the Matrix. Once we achieve artificial general intelligence, it's believed that the artificial superintelligence will emerge soon after. This is because general AI will be able to recursively self-improve and is not subject to biological limitations of organic brains. If it ever does come into existence, super AI will most likely vastly exceed all forms of human intelligence. In fact, it will likely exceed all forms of natural intelligence combined. So all three types of AI are very interesting topics to discuss for various reasons. However, in this webinar, we are just going to be focusing exclusively on artificial narrow intelligence. This is the type of AI that exists today. It's AI designed to solve a very narrow set of specific problems, but will likely revolutionize our world in the next few decades. What components does it take to make a machine intelligent? Well, there are several key components of artificial intelligence. They include perception, learning, knowledge, reasoning, and planning. Each of these components corresponds to an aspect of natural intelligence that exists in our organic brains. They also correspond to the major areas of study in AI research. While this isn't an exhaustive list, it covers the most important components of modern AI. So let's take a look at each of these five components in more detail. First, we have perception. Perception is the ability of an agent to deduce a state of the environment from sensory data. Data comes into the agent via sensors like cameras, microphones, and radar. The agent makes sense of this stream of data by recognizing patterns in the data. Through these patterns, the agent is able to detect the features of the environment, like walls, objects, and people. The aspects of these features, like their size, position, and velocity, make up the current state of the environment. Second, we have learning. Learning is the ability of an agent to extract knowledge from a stream of data. Learning involves taking in data as input and producing a decision, prediction, or an action as output. For AI agents, this involves learning how to map the state of the environment to actions that lead to a goal. We have seen a lot of progress in this space in recent years with advances in machine learning. Third, we have knowledge. Knowledge is the ability of an agent to represent what it has learned in a flexible way. Knowledge is a collection of information that the agent knows about its environment, including objects, their properties, and their relationships. So an agent knowledge can be represented symbolically as a statistical model or a knowledge graph. Each of these types of knowledge representations have its own various pros and cons. Fourth, we have reasoning. Reasoning is the ability of an agent to infer conclusions for available knowledge. Reasoning agents employ inference techniques like deduction, which uses a set of premises to reach a specific conclusion, and induction, which generalizes from a set of observations to a more general rule. Reasoning is how we use knowledge to solve problems without having to resort to trial and error for each situation. Finally, we have planning. Planning is the ability of an agent to set and achieve a goal. This typically involves constructing a set of sub goals to achieve the primary goal as well. Planning involves an agent being able to visualize future states of the environment. The agent must be able to predict how a series of possible actions will change the state of the environment and lead it either closer or further away from its goal. With this information, the agent can then choose the action that maximizes the likelihood of achieving this goal. So modern narrow AI applications do not require all five of these components of artificial intelligence. In fact, many successful narrow AI applications involve just one or two of these components. However, more general AI systems will almost certainly require all five of these components to become a reality. I'm sure we have all heard about the textbook examples of artificial intelligence. For example, robot vacuum cleaners, computers that play chess, and self-driving automobiles. However, there are many practical business applications of AI that most people are currently unaware of. Here are just a few examples of AI that are currently being used in modern business. In customer service, we have automated FAQ generators, customer support chatbots, and telephone voice assistants. In finance, we have stock market trading algorithms, fraud detection algorithms, and portfolio management agents. In healthcare, we have AI diagnostic tools, treatment recommendation, and perception verification. In manufacturing, we have AI assisted product design, industrial robots, and defect detection. In marketing, we have dynamic advertisement optimization, customer sentiment analysis, and product recommendation. And in transportation, we have warehouse robots, route optimization, and delivery drones. But this is just the tip of the iceberg. There are so many possible applications of modern AI that it's pointless to try listing them all. Anywhere you see a human performing a simple, repetitive, dangerous, or non cost effective task, there's an opportunity for automation with AI. Artificial intelligence has applications in virtually every industry in our world. If your industry hasn't been disrupted by AI, it's just a matter of time until it is.